Hello and welcome to day 26 of daily Leetcode challenges. Recording this once again a day late. Let's begin our daily challenge. Okay, question 1626, best team with no conflicts. You're a manager of a basketball team. For the upcoming tournament, you want to choose the team with the highest overall score. The score of the team is the sum of scores of all players in the team. However, the basketball team is not allowed to have conflicts. A conflict exists if a younger player has a strictly higher score than the older player. So essentially what they're saying is that you cannot choose all the players because there's two attributes representing a player: the score that they have and an age. Okay. A conflict does not occur between players of the same age. That's just more on the condition. Given two lists, scores and ages, where each scores and ages, I represents the score and age of the ith player, respectively, return the highest overall score of all possible basketball teams. And then we have two examples and an output. So, okay, so how are we to think about this? If we were to think of this naively, we could start comparing a player. We could start comparing players, right? And if we're comparing players, I'm thinking that structurally, if we were to put this in a data structure, these players, it would be nice to eliminate one of these attributes. What I mean by eliminate is eliminate the difficulty in comparing them. So, for example, if we compare the first player and the second player, we have to first compare their age and then compare their score. What if we sort the players first by age, for example? That way that when we're comparing the first to the second, we already know that the first is younger than the second, thus eliminating one of the attributes, almost like a dimension from this question. And then I'm thinking that this could actually be deduced or to a longest increasing subsequence question, because if we were to sort them by age, then the scores would essentially the scores would be the only thing that we have to compare in an array. And if it's the scores that we're comparing, the condition there is we cannot have a score be chosen later on that is smaller than the previous score that we chose. So for example, let's say that after we've sorted both of these arrays by age, the age would be something strictly increasing, but the scores now will be something messed up, right? They could be going down essentially, right? But the issue here is that we would have to choose a strictly increasing score, right? We would just by looking at this, I right away see that we're choosing this because it's strictly increasing. We can't choose this. Now, obviously, in the original form, they're all messed up, but yes. Okay, so I'm definitely linking the longest increasing subsequence array, and this question is just going to be a modification of that. If you don't know, the longest increasing subsequence is a dynamic problem, is a dynamic programming approach where essentially let me show a quick example. How would this go? It would go something like this: 1, 2, 10, 3, 4. What is the longest increasing subsequence here? Well, if you were just to keep one variable, max len here, as 0, let's see where this logic breaks. The logic, which is very simple, you compare the current, and we'll start with current index at 1. We compare the current to the previous. If the current is bigger than the previous, then we increase max len to, let's start this off as at 1. Then we increase that to 2, right? We increase it by 1. Then we look at the current and the previous. Once again, 10 is bigger than 2, we increase it by 3. But what happens when we are looking at the index of 3 and previous of index 2? It's no longer increasing. And we no longer know what the previous longest subsequence is that meets the condition of this integer being larger than this. So the solution here is to not keep just one variable, but keep n number of variables, where initially they all look like this. But as we iterate through the problem, just like we did now, we are actually increasing the number in the array that corresponds to that index. So let's see, we compare these two. They meet the criteria, they meet the conditions, so we increase this to the longest subsequence that's increasing to be 2. Here we increase it to 3. And I let you know that when we do this comparison, we no longer just look at if this current is bigger than the previous. We also have to see what is the largest previous element here in the previously filled DP array. So here, for example, when we see all of a sudden that we no longer meet the condition, we're not done yet. In order to properly fill in this DP index, we now look at the previous index that fulfills our condition, and that happens to be 2. So this is also 3, and finally, when we compare these two, it's 4, and our final answer is 4. 4 is the largest increasing subsequence. So this problem is a direct modification to that, where we're not actually counting the length of the subsequence, but we're counting the sum. So this is going to be 3, this is going to be 10 plus 3, 13. This is going to be 3 plus 3 is going to be 6, and this is going to be 10. So in this case, where we're not looking at the length but at the sum, we would actually choose this. Okay, so the modification to the array, or the modification to the longest subsequence, is that in here we're not storing the length, but we're storing the max value. Okay, and here's how we would do that. First, we agreed that we're going to sort ages and scores by age. Score is equal to sorted zip ages scores, print age scores, return 0. Let's run this quickly, and age score. And we should see that in the first case, scores, ages are already sorted, so we should see that 1, 3, 5, 10, 15 is the scores, 1, 3, 5. But in the second case, we're looking at a sorted array of sorted by age. So 1, 1, 2, 2. And here we see a 1, a 1, a 2, and 2. And the corresponding scores would be 5, 5, 4, 6, 5, 5, 4, 6. Perfect. Now that we have this sorted, we need the scores, essentially, but the sorted scores. So scores will now equal a list map of lambda of x, where x 1 and the age score as such. And now we need a DP array where we essentially just do the same thing. And now for our loop that we were talking about previously for, let's say current is equal in range I to len. Let's have a variable here, n equals len of scores. And for previous in range current, we're going to do the following. We're going to calculate the potential for our current score. The potential for our current score is going to be the previous of dp previous plus the current of the score, scores current, right? So we're looking at the max the max of the previous subsequence's score and the current. And in the condition, we're saying that if we scores the original, not the modified sum of the subsequent scores, if the original of the current is bigger or equal to scores previous, then we also need the max score equal to length. Then we're going to say that max score is equal to the max of max score potential and dp of previous is equal to the potential. And finally, we return the max score. Let's run this. We should be good. Wrong answer. Okay, wrong answer. Seems like just a condition where an edge case. Let's see if the edge case matters. If len scores is equal to 1, then return scores 0. Run. Sweet. Okay. So that should be it. Unless, no, wrong once again. The output is significant. No, it's not significant. I might have missed another thing here. And again, I'm literally following the structure of the previously solved question that has to do with the longest increasing subsequence. I did forget another slight problem here. The potential has to be greater than the potential has to be greater than the what? Than the current dp that we have figured. So okay, so here's what's going on. 1, 2, 10, 3, 4. Accidentally pressed the stop button. Continuing this video just from where we left off. If we have the case where we are comparing, let's say these two and then these two, the filling of the dp, we have to figure out, we have to have the condition that potential has to be greater than the current. And when we run this, interesting. The max current is equal to is equal to the potential. There, okay. Silly mistake. Okay. And there we go. Yep, we are beating the curve as usual. And let's see if our longest increasing subsequence is not here for some reason, but it should be. Okay, thank you. Feel free to use this code. And let's do a quick look at what other people are suggesting. Same approach, but they're using some external library, which I don't want to do. Query update int. Interesting, but no. Sorted max, sorted. Wow, best team score. Example, scores ages, dp000. Scores ages zip, exactly how we did it. Only they're sorting by score. And for score and age, for 8, score and age. Is this some matrix multiplication? Okay, I don't know. This is not intuitive to me. I think that our solution is very good. So, yep, feel free to use that, and see you later. Bye.